Imagine a herd crowned with antlers, driven like cattle across an unending white. This is not folklore. It's a brutal migration where snow, hunger, and wolves conspire to prune the living. Our question: why do antlered reindeer become trapped, starve, and face packs in Arctic storms? This video follows that single, cold curiosity to its violent answers. Reindeer, Rangifer tarandus, are both icons of winter and victims of it. We'll peel away the myth to reveal a creature shaped by ice, starvation, and relentless migration. Picture winds so strong they bury food under meters of drift. Picture a herd forced off its route by thin ice and human disturbance. Now, imagine hunger sharpening every decision. This is Arctic reality. Seasonal migration is survival. But when storms, predators, and environmental change collide, migration becomes a death march, concentrating prey into lethal bottlenecks. Throughout the tundra, the stakes are binary: move or die. Reindeer evolved to traverse impossible distances, but evolution didn't account for unprecedented storms and wolves exploiting every mistake. We will show anatomy, senses, herd dynamics, and the exact ways packs and weather turn migration into carnage. Stay with the question: why are antlered herds trapped and starved? Tone warning: this is brutal. We'll mix science with scenes that feel like a survival horror. The aim is understanding, not spectacle, but the truth is unforgiving. Keep the image of antlers, not just decoration, but functional tools and liabilities. Antlers shape how herds move, how young hide, how predators select the weak. They matter. To explain entrapment, we must start inside the animal. Anatomy, metabolism, and sensory limits determine choices on the move. Meet the body that endures the Arctic and sometimes fails. Reindeer are compact, muscular. Short legs, broad hooves that spread like snowshoes, and a heavy chest for sustained walking. Those hooves will sink into soft snow or grip ice when needed. Their antlers are skeletal scaffolds grown annually, vascular and heavy. Males and females carry them in different seasons, used to compete, clear snow, and detect rivals. Antlers reshape movement and vulnerability. Internally, reindeer pack a metabolism optimized for feast and famine. Fat deposits fuel migrations, but when winter extends or food is hidden by ice, reserves run out fast. Their fur is a thermal wonder. Hollow hairs trap air and insulate against -40. Yet insulation increases energy cost when food is scarce, a cruel trade-off in prolonged storms. Reindeer have specialized nasal passages that warm cold air and recover heat from exhaled breath. It helps survival, but breathing warm air also wastes energy when forage is gone. Their eyes shift seasonally. In winter, reindeer eyes change pigment, improving vision in blue dim light. This adaptation aids night foraging, but can't outwit a blinding whiteout or hidden predators. Nervous system. Reindeer are wired for social cohesion. Acoustic and olfactory cues coordinate migration, but panic spreads just as fast, and a stampede can lead straight over thin ice. Their senses are tuned to sparse signals. Sound travels far on frozen plains. Scent carries across ridgelines. But storms scramble those signals, leaving herds blind to safe corridors. Digestive system. Reindeer can process lichens, mosses, and fibrous grasses low in calories. That ability lets them live where others starve. But lichens take time and suffer under ice crusts. Antlers as tools. They scoop snow to reach lichen. They push rivals, and they signal dominance. But antlers also snag on drift and branches, slowing individuals and altering herd flow. Sexual dimorphism matters. Males grow heavier antlers and shed them later. During migration in late winter, this timing means large-headed bulls carry extra weight when calories are most scarce. Physiology of starvation. As fat depletes, organ function falters. Muscles waste. Hooves lose condition. Immune defense drops. Vulnerable individuals become anchors for wolves and the storm itself. Thermoregulation shifts. Reindeer reduce extremity blood flow to conserve heat. This protects core organs but increases frostbite risk in hooves and antler tips. Painful and crippling in a migration. Energy budget. Every step costs calories. A storm forces detours, sinking hooves and hauling antlers through drifts. Migration that should be efficient becomes an energy sinkhole. Cognitive limits. Reindeer remember routes, but juvenile animals and lost groups can lose that map. Disorientation during storms fractures social memory, isolating individuals at the worst possible time. Disease plays a role. Parasites, weakened by nutritional stress, become lethal. A single infection can topple a weak reindeer, turning it into an easy meal for stalking wolves. Antlers and thermoregulation interact. Despite being dead bone, antlers are vascular during growth and later heavy dead weight. They alter balance and energy, factors that matter when storms demand agility. Rangifer tarandus is shaped by migration cycles. Populations that once thrived under predictable winters now face unpredictable storm frequency, pushing anatomy against environmental limits. Human influence tightens the noose. Fences, roads, and development fragment routes. Individuals detour into perilous zones where ice breaks and predators wait, turning migration into a gamble. Those anatomical details explain susceptibility, but we need behavior to see the full picture. How do herds respond when a storm traps them against shoreline or cliff? Herding is survival. Reindeer bunch together to conserve heat and confuse predators. But in tight spaces, that same cohesion creates choke points where wolves can isolate the weakest. When wind erases scent, wolves switch tactics. They hunt by sound and vision, targeting stalled or stumbling animals. A collapsed individual becomes a flare that attracts the pack. Reindeer dig through snow to reach lichen in a behavior called cratering. But when ice seals the ground, craters yield nothing. Thousands can paw at frozen crust, wasting precious energy. Migration timing is critical. Late snowmelt or sudden storms delay movement, forcing herds into narrow windows of food scarcity and amplifying competition and mortality during those bottlenecks. Predator awareness. Reindeer use alarm calls and synchronized flight. Yet in blizzard whiteouts, visual cohesion breaks. Herds scatter, and wolves exploit isolated individuals with surgical efficiency. Wolves capitalize on geography. They drive reindeer toward river ice or cliff edges, converting terrain into traps. The storm is an accomplice, masking the wolves' approach and muffling cries. Some herds take refuge in forests. Trees block wind but reduce visibility and make movement slow. Wolves follow, waiting along game trails where weakened animals must pass one by one. Fatigue shows in gait. Stiff knees, sinking backs, and heavy breath reveal which individuals will falter. Wolves read those cues. Selection happens before the first bite. Access to salt licks and mineral-rich soils alters routes. Herds detour for nutrients. sometimes into dangerous weather corridors. Those choices are survival trades with hidden costs. Herds sometimes funnel through human-made corridors like bridges or roads. These narrow passages can become death traps in a storm, concentrating bodies and attracting predators. Calving ground selection matters. Females choose sheltered sites to birth, but when storms force herds away, calves are born in exposed places, becoming immediate targets for cold and predators. Reindeer communicate through low-frequency sounds that penetrate wind. In storms, those signals are muffled, breaking coordination and increasing the chance individuals stray from migratory corridors. Social leaders guide migration, but can fail. If elders die or routes change, inexperienced calves and yearlings lead groups into wastelands, a tragic cascade of poor choices amplified by weather. Starvation behavior includes reduced movement and risk-taking. Reindeer may approach human settlements or cross unsafe ice when the choice is faint hope versus certain decline. Wolves hunt in coordinated teams, isolating individuals, then collapsing the circle. Their strategy targets body condition and behavior, not numbers. An exhausted reindeer is effectively selected by predators. Ice crust events create crash zones where herds congregate on thin leads. Here, many get trapped, unable to dig through ice. Their presence draws wolves and seals the fate of the group. Anthropogenic noise and lights disorient migrating reindeer, pushing them into valleys or roads. These disruptions convert migration errors into lethal detours, intersecting directly with our topic of entrapment. In extreme cold, reindeer hunker and conserve energy, forming tight clusters. This increases survival for some, but makes others impossible to feed, creating micro-herding hierarchies inside the herd. When blizzards last days, hooves wear thin and are prone to infection. A limp makes an animal visible to wolves and reduces its chance to break from a funnel or reach foraging grounds. Predation leaves patterns: picked bones near river edges, tracks leading to frozen carcasses. Those patterns reveal the choreography between storms, herd panic, and the wolf's patient cruelty. Some reindeer exhibit long migrations across tundra and ice. Those epic journeys are a gamble. Success depends on timing, weather windows, and the herd's capacity to endure unexpected storms. Natural selection acts mercilessly here. Individuals poorly adapted to long detours or sudden starvation vanish first, reshaping populations and sometimes erasing local herding traditions across generations. We must also see the wolves. Their pack dynamics, memory, and landscape knowledge are honed to exploit exactly the vulnerabilities storms create in herds. Wolves practice prey parking, holding territory near choke points. They wait for days, conserving energy, until a storm or migration error delivers reindeer within striking range. Hunting is sometimes surgical. Weak animal down, others held back by scent confusion and terrain. A single collapse can trigger a chain reaction of attacks and starvation in a concentrated area. So far, body, storm, predator. Now, the social fabric. How do reindeer societies respond? Cooperation, leadership, and brutal intra-herd competition tell us more about survival under pressure. Reindeer group by age and sex outside calving season. Matriarchs lead migration routes. When elders die or paths close, social memory dissolves and herds fracture into dangerous fragments. Dominance hierarchies determine access to the best foraging craters. In scarce times, fights escalate. Antlers become weapons. Losing means less food, greater weakness, and a higher chance of being picked off. Females form creches to protect calves, but creches concentrate vulnerability. A successful wolf raid can decimate a calf cohort, with rippling consequences for the herd's future. Juveniles learn roots from elders. When migration corridors fragment, juveniles lead groups into suboptimal territories, increasing mortality and creating generational loss of knowledge. Cooperation has limits. During intense scarcity, reindeer show selfish acts, pushing others away from craters or monopolizing salt springs. Those tiny betrayals can determine who survives the storm. Mating season reshuffles social bonds. Some bulls delay shedding antlers, prioritizing competition over energy saving. That timing can be fatal when storms arrive unexpectedly during late winter. Scattered herds invite predation. Wolves prefer picking apart isolated groups rather than confronting a massive coordinated herd. Social fragmentation thus directly increases predation efficiency. Humans intersect with reindeer societies through herding and hunting. Herding can concentrate animals for protection, but it can also force unnatural movement patterns, amplifying exposure to storms and predators. Traditional knowledge once smoothed migration hazards. Modern disruptions, roads, pipelines, and climate shifts strip those buffers away, leaving herds exposed to bottlenecks we will examine next. Reproduction binds life and death in harsh ways. The breeding cycle and the calf's fragile start show how migration missteps translate to demographic collapse. Calving occurs in spring on chosen grounds. Mothers expend huge energy to birth and nurse. If migration timing shifts, calves face cold, hunger, and predation before they can outrun wolves. Reproductive strategy is high investment, 1 calf per year typically. Losing many calves in a single storm erases a year's growth, stunting population recovery for seasons to come. Females synchronize births to swamp predators, safety in numbers. But if storms scatter the herd, synchronization fails, and wolves capitalize on scattered manageable prey. Juvenile survival shapes future migration knowledge. When storms wipe out cohorts, populations lose cultural memory of roots and safe havens, increasing long-term entrapment risk. Reproductive timing clashes with climate change. Warmer autumns and late freezes scramble food availability and force reindeer into risky late movements, exacting a reproductive toll. Some populations adapt by shifting calving grounds inland or to the coast. These shifts carry new predator regimes and novel bottlenecks, often trading one threat for another. Mating skirmishes leave males weakened just as migration intensifies. Those wounded bulls are disproportionately likely to be trapped or fall prey during the harshest storms. Population cycles are natural, boom and bust linked to food and predator abundance. But human-driven changes steepen busts, preventing the slow rebound necessary for stable populations. Reproductive collapse can be sudden. A single catastrophic winter of entrapment and starvation ripples for years, reducing calf numbers and eroding herd resilience against future storms. Reindeer are ecosystem engineers. Their grazing patterns shape plant communities, control lichen, and influence nutrient cycles. Their loss would echo through tundra ecology in ways we often underestimate. When herds decline, shrubs can take over tundra, altering albedo, insulating permafrost, and accelerating warming. So the entrapment of herds has climate feedbacks, a vicious ecological loop. Predators depend on reindeer as keystone prey. Wolf populations shift in response. Too many reindeer lost in a bottleneck can starve wolves, forcing them to hunt alternative prey and reshape ecosystems. Carcasses left by storms and wolves fertilize the tundra, feeding scavengers and microbes. Death fuels life, but concentrated die-offs pollute waterways and change predator-prey balances abruptly. Humans rely on reindeer for culture, food, and livelihood. Herd collapse threatens indigenous practices and economies, creating social consequences beyond ecological devastation. Managing landscapes to preserve migration corridors can prevent entrapments. Protected routes, reduced barriers, and careful development reduce bottlenecks and interrupt the chain leading to mass starvation. Conservation is not just protection from predators. It means preserving seasonality of forage, preventing road-induced detours, and reducing noise and light pollution that push herds into harm's way. Climate mitigation matters. Fewer extreme storms mean fewer catastrophic migrations. But local interventions like installing wildlife overpasses and removing fences can have immediate life-saving impact. Scientific monitoring using collars and aerial surveys reveals pinch points where herds repeatedly get trapped. Mapping these hotspots allows targeted action to break the deadly cycles. We must weigh wolves' ecological roles too. Protective measures for reindeer must consider predator dynamics. Sudden wolf removal creates cascading imbalances and moral pitfalls. There's an ethical sting. Witnessing a herd die in a storm challenges our relationship with nature. Do we intervene, alter migration, or accept brutal ecological processes? Humanity already interferes. Roads, pipelines, and climate change shape outcomes. Choosing not to act is itself an intervention with moral weight when we know the consequences. In some communities, active herd management, moving animals, building refuges, saves lives. But such actions also domesticate wild behavior, raising questions about authenticity and long-term dependency. Killing wolves to protect herds is a blunt tool. It solves one crisis but spawns others. Ethical conservation requires nuance, landscape-scale planning instead of simple predator control. Watching reindeer suffer is disturbing, but that discomfort should fuel action. We can reduce bottlenecks, restore corridors, and support indigenous stewardship to prevent mass entrapments. Science gives us tools, telemetry, climate models, and community knowledge. Combining them can predict dangerous winters and trigger targeted interventions before herds reach the point of no return. But political will matters. Funding, policy, and respect for native land rights determine whether mitigation moves from theory to reality or remains a distant promise. We've traced the chain: anatomy and antlers, storm dynamics, migration errors, predators exploiting weakness, reproductive collapse, and ecological fallout. It's a single thread pulling whole communities toward disaster. The central mystery, why antlered herds become trapped and starve, resolves into a compound answer. Biology meets weather, meets landscape fragmentation, and predators finish the job. Rangifer tarandus is neither noble nor merely picturesque here. It's a species constrained by anatomy, culture, and a changing world that makes migration a perilous gamble. So what do we do with this knowledge? We can act to keep corridors open, fund monitoring, and support local stewards who know the land and the animals intimately. There is no tidy solution. Interventions carry costs and moral trade-offs, but doing nothing condemns herds to repeatable, preventable tragedies beneath indifferent skies. If you care, learn which projects protect migration routes, support indigenous management, and demand infrastructure planning that considers the lives crossing it. Small policy shifts save thousands of lives. Remember the image of antlers against a white storm, a silhouette of survival and fragility. Each antler tells a history of migration, hunger, resilience, and the threat of extinction. The Christmas reindeer of story are icons, but real Rangifer tarandus endure horror we rarely see. Learn, act, and let that knowledge haunt policy halls so the tundra keeps breathing.